Hello everyone, my name is Dinoza and today I will talk about catalysis and surface chemistry. How surfaces and catalysts can make chemical reactions faster. The aim of this presentation is to explain how surface and catalysts make chemical reactions faster. To achieve this aim, we will follow these objectives to describe what catalysis and surface chemistry mean, to show the difference between homogeneous and heterogeneous catalysis, to demonstrate two experiments, elephants toothpaste and sugar dissolving, to show real-life examples in cars, in modern technology and in our body. So let's start. First of all, let's look at this question. What is the rate of reaction? It means how slow or fast a chemical reaction happens. For example, some reactions are very fast, like burning a paper. However, some are slow, like iron rusting. So, what makes reaction go fast or slow? We can change the rate of reaction in different ways, by changing concentration, by changing pressure, by changing temperature of reaction, and by increasing surface area of reactants, and by using catalysts. And today we will focus on surface and catalyst. What is a catalysis? Catalysis is a process that makes a chemical reaction go faster. The substance that helps is called a catalyst. Catalyst helps but doesn't change or disappear after the reaction. We can see this idea in our daily life too. When we bake a bread, we use yeast. Yeast is like a catalyst for baking bread. Yeast helps to sugar change into gas and bread rises faster. Yeast helps but doesn't change by itself. So that's what a catalyst does in chemistry. So we have two main types of catalysis: homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis, when the catalyst and reactants in same phases. Both are liquids, both are gases. Heterogeneous catalysis, when the reactants and catalyst in the different phases. For example, we have a solid catalyst and reactants, liquid or gases. So heterogeneous catalysis very important in solid state chemistry, surface chemistry, because reaction happens on the surface of the solid. So let's look at the experiment which more explain heterogeneous catalysis. Now let's see a colorful and fun experiment named elephant toothpaste. It's a good example for heterogeneous catalysis. So for this experiment I will use hydrogen peroxide, which is a liquid, and as a catalyst I will use potassium iodide, which is salt, and I will use also soap, and I will add food coloring for making this experiment more visible. So let's start. So normally hydrogen peroxide breaks into water and oxygen very slowly if we just leave it open. So when we use a catalyst, the reaction becomes more faster. So here hydrogen peroxide and salt. I'll mix it. So, and here we add potassium iodide. I forgot food coloring. I will add it also because it makes the experiments more visible and colorful. So let's look. So here we can see produced oxygen in form is oxygen. We see. So for this experiment is catalyst used potassium iodide, which is a salt substance. So here we can see our reaction of experiment. So this shows how a salt surface can speed up reaction in liquids. This is one of the main ideas in solid state chemistry and surface chemistry too. So let's move on to surface chemistry. So next question is, what is surface chemistry? Surface chemistry studies what happens on surface of the solid. As a solid can be metals, salts and gases. In real life we have more examples for surface chemistry. For example, when we paint a wall, the paint covers only surface of the wall. When iron rusts, it happens only surface on surface of the metals. Yes. When we use toothpaste, it cleans only surface of the teeth. Yes. Surface chemistry helps us understand how molecules meet, stick and react on solid surfaces. Sugar dissolving. We can see surface chemistry even in our kitchen too. When we put a sugar cube in a tea or water, it melts. Here, it melts very slowly. Here we can see it melts very slowly. So, but powdered sugar melts much faster. Why? Because small sugar pieces have more surface area. More surface means more contact with water. This shows that the bigger the surface, the faster the reaction or process. Surface chemistry and solid state chemistry used in real life everywhere. use it. For example, here in cars, we have a small device named catalytic converter. Inside here, we can see a metal, platinum or palladium. Yes, it can be. So when dirty gases touch the surface of the metal, they change into clean gases. So it helps keep our air clean. Next example, in our body also uses catalysis named enzymes. Enzymes helps digest food and control in our body chemical reactions quickly and safely. So next example, nanocatalysts. Scientists makes nanocatalysts with tiny participants and with huge surface area. This used in medicine and in our batteries and clean energy. To sum up, I hope that we reached our aim today. We learned how surfaces and catalysts make reaction faster. Catalysts are special helpers. They help reaction happen faster, but they don't change themselves. We saw this in our experiments and real-life examples. In elephant toothpaste, sugar dissolving cars, modern technology, and our body. Understanding surface and solid-state chemistry helps scientists create clean air and better materials for the future. Let's take a look at the references. I use it. Here I use it reliable sources. The sources help me to prepare accurate and clean information for this presentation. Thank you for listening.